So today we are going to learn how to use AISC design menu to do the beam design. Let's grab the steel menu. So this is the part 3 I just mentioned. If we go to the table 3-1, you can see that's all the calculation for the CB value, which means if you had simply supported beam under the concentrated load and the lateral supports only at the support, then your CB value will be 1.32. So make sure when you use this table, your situation, the boundary condition, the load condition needs to match every picture here. Otherwise, you need to go back to chapter F, use this equation to calculate CB, which is F1-1. And then let's go to the table 3-2. So you can see this table is actually for the I-beam, the W shape, and organized by the ZX. So basically this table had a design section, and we had a Z value, and you can see the PMP, which is the design plastic moment, and design the elastic moment had already listed here. You can just follow your plastic lens or the elastic lens to help you pick the section, and then you should be able to find the right section for your beam. And then by the end of this column here, you can see that's for the shear. We are going to use this table later when we do the shear check. And then if you go to the table 3-3, that's actually organized by the moment of inertia. So basically you can find all the information in the table 1. However, this is just another shortcut so that you don't need to go back to the table 1 to grab all the moment of inertia. So table 3-4 is actually going to be the ZY. So which means if your beam was set it in the weak direction and you have to design your beam by using the ZY, you can go to this table to find out all the values. And table 3-5, again, that's a property for the IY. If you go to the table 3-6, that's actually going to be the I-beam under the uniformly distributed load. So it's very similarly like the compression member. If you had the load, the length, and then you can try to read what is the maximum moment you can handle for your beam. And then the table 3-7 will be the same, but for the S shape. So table 3-8 will be the C channel under the uniformly load. 3-9 will be the Massillon C channel. And then we are going to go to the table 3-10 and 11. I'm going to talk about this later after I introduce the table 3-12. So basically 3-12 is if you are going to use HSS as your beam, you go to this table to find your section. If you are using the pipe, then you are going to use table 3-15. And then the other charts here, table 3-16 and 17, that's actually for the shear. We are going to talk about this later when we do the shear design. And then if you are keep flipping, that's composite W shape, which means if you are composite with the concrete slab, then what you are going to do. And But if you go to the table 3-23, that's what we are going to use later for the deflection check. Or you can try to check with the moment diagram to help you calculate CB if needed. Alright, so let's go back to the table 3-10. And you can see a lot of lines here. And what are those, right? That's what you are wondering. So basically the table 3-10 and 3-11 is actually the design charts for the W section. I wrote this wrong. C channel and Mersenne C. However, whenever you use this table, keep it in mind the CB is actually equals to 1 for all the tables. And basically every W section or the C channel is going to have the curve like this. However, they are so big. That's why they have to be break it into several pages to finish the charts. No matter what will happen, we need to keep it in the mind that this horizontal limit, the horizontal line here means the plastic moment, which means you are going to use the plastic section modulus, which is the Z, to do the calculation. And the length respect to this is going to be LP, which is the plastic supported length. And then we are going to have another critical kind of moment here, which is the elastic moment. We can calculate this by using the mechanics of materials. And then the length here is going to be called LR.